Hi, welcome to this new video in the series of applied econometrics. In this video, I'll talk about sampling and the sampling distribution. A sampling is a process of selecting a part of the population to know or to conclude about the characteristics of the population. So, to explain what the sampling is, let us consider that have a population of 25 guys over here, and we're going to select a few guys. Let us say 8 guys out of the 25 guys. So the process by which we select these 8 guys out of the 25 is called sampling in the language of statistics. So one way to select 8 guys is just to use a lottery method uh, in which we randomly select 8 out of this 25. So the 8 guys might be the guys that are in the shaded circle. So in this case, the 25 guys is the size of the population, which we denote by capital N in most cases. So capital N is 25, and we are selecting 8 guys, which is called the sample size. So here small n is 8. So sample size is 8. Sample size is the size of the items that are selected from the population in order to know something about the population or in order to conclude about the characteristics of the population. One important concept is the difference between sample statistics and population parameter. Sample statistics is the value that is calculated from the sample points. In our instance, for example, the sample size was 8, and any statistical measure calculated by using the 8 observation is called sample statistics. For instance, sample mean can be calculated as x bar equals summation x over n. So this in our example is calculated out of the information of 8 guides. That is out of the information of the sample. Whereas population parameter is the value that is calculated from the whole population. So in case of mean, the population mean, which is the population parameter, because population mean is calculated from the information of the whole sample, is denoted by mu instead of x bar and is given by summation x divided by capital N. So capital N is the size of the population. So in our instance, it was 25. So in case when the population size is rather small, we can calculate the population parameter. If we can calculate population parameter, there is no point in taking a sample and taking the sample statistics as an estimator. Just like in our overly simplistic example, there are only 25 individuals in the population, and we can easily find the population mean, which is the population parameter. In this case, there is no sense, it doesn't make any sense for taking a sample and using the sample mean as an estimate of the population mean. So, but in reality, the population is quite large, and it is often impossible to calculate the population parameter. In that case, the population parameter cannot be calculated, so we try to estimate it by using the sample statistic. So just I talked in our example, which is rather a overly simplistic example. Here the sample is statistics. The sample is statistics, for example, the sample mean, sample median, sample standard deviation is calculated from the guys that are selected in the sample. From the 8 guys, n equals to 8, and the population parameter mu, population standard deviation sigma, it is to be calculated from the whole 25 guys. So one useful differentiation is useful to know, that is between random and non-random sampling. The main difference between random and non-random sampling is the way of selecting the sample. If we select the sample from the population item in such a way that each item in the population has some probability of being selected in the sample, it is called random sampling. For instance, if we use the lottery principle or the random number selection by the computer, it is called random sampling. So this is called a scientific sampling procedure, which leaves less bias because there is no role of personal judgment of the researcher. Whereas in non-random sampling, personal judgment and convenience has a lot of role, and the results from such sampling mechanism has possibility of bias. For instance, in this case, if we use lottery, 25 lotteries, for example, if we make paper slips numbered from 1 to 25, and by using blindfold method select any eight paper sheets out of those 25. Any of the 25 has probability of being selected. So this is random sampling. Whereas suppose we are here, we as a researcher are here, and we say that this guy is quite close to us, so it is very easy to contact him, so we just select this one. This guy is very far from us, so it takes a lot of time to meet him, so this guy should not be selected. This guy is not available all the time, so this guy should not be selected. This guy is quite nice, talks nicely, so this guy should be selected. Or this guy is quite rich, so this should be selected. So if we use this type of personal judgments criteria to select the sample, it is called non-random sampling. That's why the non-random sampling is not going to provide you with a bias-free sample. Next concept is about sampling distribution of statistics. Sampling distribution is perhaps one of the most difficult concept to visualize in the beginning. It is because it is related to the repeated sampling, which we do not observe in practice. In practice, we take sample only once. For example, in our previous example of 25 guides, once we select 8 guys out of the 25, we are done. and we never repeat this process and take another sample of 8 guys and take another sample of 8 guys in practice. So sampling distribution is related with this case of repeated sampling. Sampling distribution is simply the distribution of the sample statistic in the repeated sample. So to explain this with an example, let us consider that the population has only 5 numbers. So this is also a very overly simplistic example, but it is sufficient to grasp the concept of sampling distribution here. So there are 5 elements in the population, capital N is 5, and we're going to take a sample of size 2 from this sample of size 2 from the population. So we can select 2 numbers out of these 5 numbers in very many ways. Some possible ways can be 1 and 3 and 2 and 5. So there are 2 possible samples. In real life, not both of them are realized. Only one of them is realized when we select one sample. Now we are going to calculate a sample statistics. For example, sample mean when our first sample is realized. So in this case, sample mean is 1 plus 3 divided by 2, which is 2. If we select another sample, and for example 2 and 5 are selected, we can again calculate the sample mean. So the sample mean in this case will be 2 plus 5 divided by 2, which is 3.5, which is 2 plus 5 divided by 2 is 3.5. So if we take repeated samples and calculate the sample mean, the resulting distribution is called the sampling distribution of the sample mean. So we list all the possible samples and calculate the sample mean in order to get the sampling distribution. So this has been done in Excel here. Our approach here is to take a sample without replacement, so the same number cannot be selected. So once we select, so these are our all possible samples of size 2 out of the population having these 5 numbers. So this is population, these are the possible samples. So once one is selected, once the number 1 is selected, then it is not returned back to the population. So in the next place, 1 cannot be selected. So the possible samples can be 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, 4, 5. So in this case, selecting 2 and 5 is the same as selecting 5 and 2, so we have not listed them separately. So there are altogether 10 possible samples, which can also be calculated by the combination formula 5 choose 2, 5C2. So out of 5 numbers, we are selecting a sample of size 2. So this is 5C2, which is factorial 5 divided by 5 minus 2, which is 3 factorial times 2 factorial. So this is 5 into 4 into factorial 3 over 3 factorial into 2. So this is 2 is 10. So there are 10 possible ways to select 2 numbers out of 10, or there are 10 different possible samples. So now we calculate the sample mean. In each case, the sample mean in the first case is 1.5, second case is 2, and we calculate sample means in all the possible 10 cases. So the list of all possible sample means, which is also the sample statistic in this case. So the list of all sample means is the sampling distribution of sample means. So this sampling distribution of sample mean can also be presented in terms of graph. In this case, we have created a histogram of the sampling distribution of sample means. So sampling distribution has a great role to play in econometric methodology. Before that, one important point to remember is that just like the sample mean, there is a sampling distribution of sample standard deviation, sampling distribution of sample median, sampling distribution of regression coefficient. In summary, every sample statistics has its sampling distribution. Sampling distribution shows the underlying uncertainty in the estimation process. So it shows the uncertainty in the estimation process. What does this uncertainty term refers is that, for instance, in our example, if we take the first sample mean is 1.5. So if we conclude that population mean is 1.5, on the basis of this, our estimate of the population mean will be 1.5. And in this sample, the sample mean is 4.5, and if we conclude that population mean is 4.5 on the basis of this sample, the estimate of the population mean will be 4.5. So the sampling distribution of sample mean goes from 1.5 to 4.5. So imagine now a situation where the sample mean ranges from 2.9 to 3.2 only. So in our case, the population mean can be calculated easily, which is 3. So now compare these two sampling distributions. So in this case, the sampling distribution has a greater variability from 1.5 to 4.5. So our estimate of the population mean has greater uncertainty. Sometimes we say that population mean is 1.5, sometimes we say that population mean is 4.5. So we are very far away from the true population mean, which is 3 in our case. But if the sampling distribution of X bar just ranges from 2.9 to 3.2, so our mistake of making an estimate of the population mean is not that much large. So in this sense, the sampling distribution gives us an idea about the uncertainty in the estimation process of population parameter. The flatter the distribution, the larger the uncertainty. So this can be explained with 3 different possible sampling distribution. In this case, the true population value is 80. Suppose we are going to make an estimate about the true population value, and this distribution is quite flat. So there is large uncertainty because sometimes our sample says that the population value should be here somewhere 40. Sometimes it says that the population value should be 120. So we are quite far away from the true value, or there is greater uncertainty. So when we move from this sampling distribution to this, The uncertainty for estimating the true value becomes smaller and smaller, and in this case we are quite close to the true population value and our estimate are quite closer. Thank you for watching this video, and in the next video I will discuss about the